Hey everyone, I hope you all are safe and doing good. So, from this lecture, we are going to start data structure and algorithm, and this is the very first lecture of our DSA. So, in this lecture, we will see some introduction to data structure and algorithm. Means what we'll discuss in this lecture basically what is data structure, what are algorithms, and why we need data structure. What is importance of DSA, importance of data structure and algorithm. The basic things we'll discuss in this lecture. Okay. See, now let's discuss first what is data structure. So, as the name suggests, data structure, there are two words data and structure. Let's just understand separately these terms. What is data? Data is nothing but it's like some raw facts, right? Unprocessed data is unprocessed. I guess you have heard these two things data and information. These two things. Let me just show you this thing data plus information. I mean, data and information. So, data is different, information is different. Data is raw facts or figures or unorganized things. Data needs to be processed. Information is after processing, you get information. You get some valuable information. Like maybe data is like in my class, marks of 60 students. This is like data. And after doing some processing, I can just say that average marks in my class is whatever the marks is there and highest marks is this something like this. So after analyzing that data, after processing the data, I get some information that is valuable for me. So that is information. Okay. So data is basically what is raw. It's raw, unorganized, or you can say unprocessed, raw facts or figures. These are data that need to be processed. It can be simple and at first glance seems some random and useless kind of thing. Like data can be like there are so many videos on the YouTube. But suppose I want videos of DSA, data structure and algorithm, or Java. So the Java videos or DSA videos are useful for me. So that is kind of information for me. All the other kind of videos are just data for me. Okay, this kind of thing you can relate. So after processing the data, after doing some processing on the data, we get information. But information is not topic of this lecture. We just need to understand what is data. Okay. Now data can be it can be numbers, it can be like text, audio, video, in any form data can be there. Okay. Like we have a list of numbers 10, 20, 30, something like this. So this is kind of data. And if you calculate like average, after doing some processing on this data, I'm going to calculate average. So this is kind of, we can say information for me. I need average. Okay. So this is the thing, right? Like a student information, consider a student's information, name, age, grade, address. So each piece like name, age, grade, and this is a single unit of data, right? Now, what is structure? As the name suggests, structure. It basically refers a way the data is organized and related with each other. That is structure. Okay. It defines the relationship between different pieces of data. Like let's take a real life example. In our home also, there is data can be like whatever you have in your home. Like in kitchen, we have some containers. There we have something, some spices and all. We have our clothes, we have heels, we have some appliance and all. This is like kind of data in our home. And the structure is it's not like that everything is mixed up in our home. No, there is a kitchen, we have drawers and everything we put there in shelf, all the kitchen item, our clothes, our heels and everything. Like our clothes, for our clothes we have almirah or the wardrobe, there we put our clothes in properly organized way. So that almirah is kind of a structure for putting the clothes is like clothes are like data. Kitchen containers or those things are like data, and those kitchen drawers, and we have like modular kitchen nowadays. So that is like a structure to put to organize that data. So that is basically structure, nothing else. I hope you get this. Okay. Like a bookshelf, it's a structure. We can organize books in a structure by their size, by their genre, alphabetically, so that we can easily access these things. Okay. In library also we have those shelf. So those are nothing but structure to organize those books are nothing but like it's like data. Okay. So that is structure. Now data structure is combination of these two, data plus structure. So it's like we can say, see, what is data structure now? Combining data and structure. So data structure is a way of organizing and storing the data in computer, or basically mainly if I say then computer's main memory, so that it can be used efficiently. So it's all about arrangement of the data in the main memory. Because on data we perform some operations, we know. If you write any program, we need data. Like if you want to write addition of two numbers, so that two numbers you give is like data. Every application use data structure. Every program, every application needs some data. We process on that data, we get some output, right? Like sorting. If you want to find out sorting of numbers, so those numbers you input is like data. Then do some processing and then you get the output, the sorted data. So in every program, for everything we need data, we know in some way. Maybe it's numbers like textual data, or numbers, or you can say images, audios, videos, or any kind of data can be there. We need data. So if you need data, then you have to organize that data as well. So for that organization of that data, we need some structure. We need some, it's like in computer term, you can say it's data structure. So we need some arrangement. So it's all about like arrangement of the data, so that the operations you want to perform on that data can be performed efficiently, whether it's updation of the data or accessing that data or insertion or deletion, any operation. Okay. Every application need data. Like application, it's like you can say Facebook, Instagram, social media apps. These are having billions of users and the data. So they have to manage that. They're having some data structure. Using data structure, they are having some algorithms. Okay. So DSA is the fundamental kind of thing, right? So uh, I hope you got this. The general meaning of data structure. It's a way of organizing and storing the data in computer's main memory so that it can be used efficiently. Right? Now, real life example is like it's a recipe book. So you can think of a recipe book, and there are so many recipes of different you can say items. These are organized in some sections, structured way, for main course, for dessert, for something like this. And whenever you want to access anything, you just go to that section and that's it. Right? So this organization allows you to quickly find a specific recipe when you need it, because you can start the section it belongs to. Okay, it's like you can say in a library there are so many books, thousands of books, and every it's kind of every there is no structure in that library, and all the books are like placed in a messy kind of thing. Okay, there are so many books, thousands of books. There is no proper organization of those books. Okay, like every books are like mixed with each other and something like this. So if you want to find a particular book, then what will happen? Definitely you need more time, because there are suppose 1,000 books, right? Second way is, if books are properly organized, if the data is properly organized in properly those shelf according to the section, like here we have a fictional book, non-fictional book, or in subject wise you can say computer science book, or electronic, electrical. In your library also, in your college library, books are arranged something like this: computer science section, electrical, electronics books, and novels, or something like this. In computer science also, you have some maybe different shelf, or these are like first semester book, second semester book, or Java book, or these kind of books. So if a computer science student comes, he can directly go to that computer science section and find the book easily if the books are properly organized in those shelves. If not organized, then it will take longer to find a book. Yes. So that's why we need organization of data, and that's why we need data structure. So in computers memory also, every application need data structure. So it's like we can say for that, let me just show you first what is a program. Let's understand that thing. We know program is a those set of instructions, okay, that tells the computer how to perform a specific task. We write a program addition of two numbers, so that is nothing but a set of instructions. We are telling the computer that you have to do addition of two number by just, because computer is not having its own brain, so you have to tell everything in instruction. So that is kind of like program. We are writing programs. Many programs we have written till now also. Okay. And Almost in every program we use data. So every program there is some input, we input some data, then processing is done, then we get some output kind of thing. Yes. So it manipulates data to achieve a specific task, to solve a specific problem or to solve a specific task. That is simple a program, set of instructions. Okay, that tell a computer what to do. Yes. Now, the program needs some data, right? If that data is not organized, then what will happen? I have given you a simple real life example also. If you don't use any good data structure, then definitely the execution time would be increased. Okay, that program would not be efficient. So we organize that data, whatever is used in that program, using a data structure. And data structure can be anything. There are so many data structure: array, linked list, stack, queues, heaps, trees, graphs, tries, priority queues. Many data structures are there. Now, based on your requirement, your program requirement, your project requirement, your application requirement, we need different type of data structure. That also we'll see in later videos one by one, when to use which one. Okay. Now, see, programs operate on data. Now we have to organize the data. If you do not organize, what will happen? I have told you. So we organize the data. So the way data is organized, that is like data structure. This significantly impact the program's efficiency. Okay. So we have to choose right data structure. Now, what happened basically where this data structure works? See, I've told you that organization of the data or arrangement of the data is simply data structure, so that the operation we perform on the data can be more efficient. We can access the data efficiently. We can update that thing. We can insert something, insert in that data or delete something efficiently in less time. Okay, we can access that data efficiently. That's why we organize the data. So it's like we can say something like this. Uh, it's in main memory basically. Organization of the data is in main memory. So suppose you have a program and you need some data like this. Let me just show you this thing. We have this memory, main memory. Okay. And this is a hard drive. So CPU is there, which will be interacting with this. So there is a program. So whenever you run that program, that would be loaded into the main memory, we know. And if that program needs some data, if there is some file, in there we have some data. So that data will also be loaded in the main memory. Yes. Now, this in main memory, the arrangement of the data or the structure of the data or the organization of the data is known as data structure. We use a data structure to organize the data in main memory, not in hard drive. So, main data structure role is in the main memory only. Okay, because there are so many things. We have databases, we have data warehouses, we have data structure. There we use this term data. So, data structure basically in the main memory, organization of the arrangement of the data in main memory, that is basically data structure. Okay. Database, in database we generally store data in like tabular form or relational form. That is nothing but tabular form. So that is in hard drive basically, databases. Okay. But data structure is in main memory. So that's why in the previous video also, in the previous slide I have told you data structure, organization of the data in the computer's main memory. Specifically I have told you in main memory. Okay, like whenever you run any application, suppose I'm running notepad, we write program in notepad na? Sometimes. So we have stored that thing here. Okay, now there is a notepad file also, notepad file, and there we have suppose abc.txt, where abc dot any txt, suppose txt, this is the notepad file. So whenever you click on that notepad icon, that notepad program would be first loaded into main memory, then it would be executed and you will see that notepad on your screen, and those option like file or something like this option you will get here in that menu bar, because the program has been loaded here and that has been executed. Now if you click on any like abc.txt, there we have some kind of data, so that also be loaded here first and then it would be shown to you. Okay, so both the That this program, the application program or the code file would be first loaded, and then the data is also loaded here in the main memory. Okay, that's how we it's working internally. So basically every application is using some data structure. So both the program and the data has to be in main memory, right? So I told you what is data structure. Now, choosing the right data structure is really important for writing efficient and effective programs. That's very important. Now, basically, data structure, I've told you that organization of the data or arrangement of the data in simple terms is data structure. That's it, right? Now, how to organize that data, that also matters. Like, suppose I'm having many books here. Okay. Now, I suppose put all the books something like this. Now, right now, there is a chair in my like room, and I was just having some cleaning kind of thing here. So I have put all the books. There are like, I guess, 10 or 20 books. So I have put all the books something like this, one upon another on the chair. So if suppose I want to take that one book, which is, I guess, in the last, and every book is on the top of that book. So it's very difficult for me to take that book from there, to access that book. Yes. But suppose if there are something shelf kind of thing, there I just put the book something like this. Here, then one book, third book, something like this. All the 50 books or the 10 books. So by looking at this, I can easily pick or access that book. So the organization matters. Which data structure you are using, that also matters. Where to use arrays, where to use linked list, where to use tag, where to use heap or trees or graphs. These things matters. Choosing a right data structure is really, really important. It's not like that just use data structure. We have organized the data. No, I have organized my books. I've just put all my books. I've just kept all my books on the chair. All the like 20 or 30 books. But it's really difficult for me to access any book. Okay. So that structure or that arrangement is not working for me. Like if you have, it's like if you are going somewhere, if you are going on a trip and you want to pack your suitcase. So it's not like that you just put all the clothes there randomly. So the suitcase will be filled, soon, and maybe you need some extra bag also. So it's like wastage of space. You are not organizing that data. You are not putting your clothes properly in that suitcase. But one way is you just fold your clothes properly, maybe roll your clothes and maybe roll your socks and just fill those socks or put those socks in the gaps, something like this. So better, the second way is better. Properly folding your clothes or rolling your clothes and putting in that suitcase. So in that case, maybe you do not require an extra bag because you have organized that data properly. You have used a second technique, another technique to pack your bag. Okay. So that's why choosing the right data structure is really important to write efficient programs. It makes the program more readable, maintainable, and scalable, more efficient. Okay. So we can say here one thing more. Now, see, I've told you this data structure is like organization of the data or arrangement of the data. But why to organize data? I guess the answer of this question we have already discussed. If I ask you why you organize the data, the answer is very simple. For efficient accessing of the data. Like in a library, if you put everything, all the books in unorganized way, then it will be really tough for you to find a book, or maybe it will take longer time to find a particular book. But if you arrange in that library, if books are properly arranged according to the in the shelf, according to the section, and maybe alphabetically, you can easily find out that book. That's why we organize the data, right? We keep everything organized. In an almirah, we keep our almirah organized. Like in one shelf we are I'm having my top, then jeans, then in one I'm having my heels, and then accessories and different kind of thing. It's not like that everything is mixed up. Okay. So that's why we know organization of data is important. right? For efficiency, organized data allow for faster accessing, we know, faster searching, faster accessing, faster sorting, and these things. So efficiency would be more. Yes, your program will take less time to run if the data is properly organized. Okay. Management, it simplifies the data management, making it easier to update the data, insert or delete something to the data if you want to do something, this kind of thing. Okay. Storage, efficient data structure optimize the storage space. Also, you need less memory. If you organize the data properly, you need less memory to store that data. Same like if you are packing your bag, and if you have 50 clothes, if you do not organize that properly, just fill, put in the suitcase, something like this, maybe you need an extra suitcase. But same, if you organize, fold those clothes properly, roll some clothes and put in the gaps, then maybe you do not require an extra bag. So it's like saving of the space. In computers terms, saving of the memory. Okay. So efficient data structure optimize the storage space, reducing the memory uses or memory requirement. That's why we organize the data. And to organize the data, that's why we need data structure. Okay. I hope you got this. Next we have is, now what is algorithm? It's very simple. We have already discussed this thing also in the very first lecture also. You can go and check out. But in brief, I am going to tell you. Algorithm, to be specifically, somewhere you said you will find that it's a set of instructions or step by step procedure. We know it's a step by step procedure to solve a problem. That is algorithm. It in simple terms also, like it's not like that algorithm is used in only like computer science, uh, in computer science only. In simple term, in real life also, algorithm is like, it's a recipe. If you are going to make a tea, then there are some steps. Boil water, then add tea leaves, then add some, you can say, milk and sugar, and then keep boiling for like 2 to 3 minutes, and that's it. So there are some steps. We follow those steps, and ultimately you get your tea. So those steps are nothing but algorithm. How to do that task? Algorithm simply we write in English language. So in computer science uh, context, if I say, then algorithm, we can say it's a finite sequence of steps. More precisely, this is the exact definition. Sometimes somewhere you say that it's a set of steps or set of instructions. No, not set. These are sequence. Okay, because set are basically unordered. There is no order in set. Sequence is like ordered kind of thing, ordered list. And algorithm is obviously ordered. First, like if you are going to make tea, then it's not like that. First, you put like maybe sugar. First, put sugar, then milk, then tea leaves, then water. At last, maybe like switch on the gas and all. No, maybe sometimes you can do that thing also, and ultimately you will get tea, but that's a different case. Exact process is, switch on the gas first, switch on the that flame, then boil water, add tea leaves, then boil for some time, then add, you can say, milk, sugar. This is the exact like process. So these should be, these are a, this is a order. You have to follow that order. First this step, then this, then this, then this. Otherwise you will not get correct output. Like for teaching also, I follow a proper algorithm, na? Steps. I first teach the basics, like what is data structure. I'm teaching you what is data structure, what is algorithm, then I will go for arrays, linked list and all. It's not like that I first directly cover that algorithms, dynamic programming or backtracking, then in reverse order at last I'm telling you what is data structure. That is not a correct way. So these should be in some order. Something like this, you can say related with this. So this is a finite sequence of steps or instructions to solve a specific problem. That is algorithm. We generally write algorithm in simple English language. Okay. Finite, obviously, step should be finite. For making a tea, there are 5 6 steps. These are finite. We know. For making something else, for making idli or some other kind of thing, there are finite steps. These are not infinite steps. We know. So that's why algorithm is having finite sequence of steps. right? This is algorithm. Now, like process of making tea is an algorithm. So there are some characteristics of algorithm. First, finite. Algorithm must always terminate after a finite number of steps. That is for sure. Step should not be infinity. Then each step must be clear and unambiguous. It should not be ambiguous. It should be unambiguous. It should be clear. Each step, what to do. You have to clearly mention because computer cannot understand, cannot, don't have its own brain. So you have to clearly mention, do this thing, and it will do that thing only. To clearly mention that thing. So algorithm, each step should be clear. Algorithm can have accept some input, one or more input, maybe zero input, one or set of inputs, and that will give you maybe one output or some set of outputs. Okay, that is possible. Like making a tea. So you are having some ingredients so that are input, and at last you will get one output, that is your tea. So it will give you, must produce at least one or more well defined outputs. Okay, and algorithm should be like general. It should not work for a special case. It should cover all the cases. Should be applicable to a wide range of inputs, not just a special case. Okay. So it should be like general kind of thing. So next is, and see now, if you say that I am not going to prepare tea something like this. I boil water, I take a like tea bag, I put that tea bag into the cup, then pour the boil water, then add maybe sugar or milk. So your algorithm or your steps of your recipe is different. That's possible. For making a tea, there can be many algorithms. So that's why in computer science also, for solving a problem, there can be many algorithms. There are many techniques. Okay. And implementation of the algorithm is also different. Like I just told you at one step, first step is boil water. That is first step. Now implementation, first step is boil water. So maybe you are going to boil water on the stove, on gas, or in kettle, or in somewhere else. So how to boil water, the implementation is different. So implementation of each step may be different, right? For each algorithm, for each step, its implementation can be different. I can boil water in many ways. It's not like that I have to boil water on the gas only. No. There are many ways to boil water. I can use a kettle also. Ultimately, the goal is boil water. I'm not saying that boil water on gas only. So that's why every algorithm, each step can have different implementation as well. When you do program, when you write program, there can be many ways to implement that algorithm. Okay. And to solve a problem, there can be many algorithms. So we have to choose the efficient one. Generally, we use the efficient one, which take less time. Like we consider space complexity, time complexity. So generally, that take less time complexity and less space complexity. That is considered as efficient algorithm, and this is basically known as analysis of algorithm. That we analyze the algorithm with big O notations or theta notation or these things. So that thing we'll see how to analyze the algorithm. So, like in real life, we can say if you are traveling from one location to another location, so there can be many ways. You can go by air, by bus, by train, by your own vehicle, and there are so many routes as well. So, according to your suitability, you will choose a particular path to go from one to another. There are so many conditions. So based on that, you will choose. So like this in computer science, also there are so many algorithms. Like for sorting, if you want to sort some numbers, there are so many algorithms. Bubble sort, insertion, quick, merge, selection. There are many sorts. Based on your requirement of the problem statement, based on your problem statement, based on your application, based on your need, we choose, like you choose the type of algorithm you use. Generally, we use like what is the optimized one, which is taking less time complexity and less space complexity. Okay. So that is all about algorithm, and I've told you those properties of algorithm as well. Now, importance of data structure. why we need basically data structure. So I guess you can easily answer this question. Why we need data structure and why we need like algorithms? For efficient data storage and access. Like you take, if you have a messy room, everything is like your clothes and your heels and your books and everything in your room is like unorganized, scattered. And you have organized everything in almirah, in bookshelf. You have books in almirah, you have your clothes properly organized in wardrobe, in your you have heels, your shoes and everything. So you can easily access everything in less time if the data is properly organized. So that's why we need data structure to organize that data. We know that like data structures are basically essential for organizing, storing and arranging that data so that we can perform the operations efficiently on that data. Without data structure, without organizing the data, your program would be slow. It would not be manageable. It will take more time. Okay. Second thing we can say, obviously, when you organize the data, then faster accessing, faster searching, faster sorting would be there. If data is properly organized, you can easily access anything. Like in a library, you can easily access a book if it is properly organized. Suppose uh, in your you have written your friend's phone number in a random book, in a random like notebook. So while searching for a phone number, it is taking longer time. But if the same phone numbers are arranged alphabetically in your phone's contact number, then you can easily access that thing. That is kind of example of BST, binary search tree. Like in dictionary also we have this thing. Alphabetically order, everything is arranged. A, B, C, D kind of thing. So if you want to find out the meaning of a particular word, you don't need to search the complete dictionary. And there are thousands of words there. If they are not properly arranged, then it would be really difficult for you to search meaning of a simple item, meaning of a simple word. But if you want to find out a meaning of, like I want to find out a meaning of laptop, so I just go to simply where is L, alphabet L, then after that L A, then P and T O P, something like this, and we can easily find out. So that is kind of binary search tree. We use this kind of thing. I'll tell you in later section like what is binary search tree. So this is kind of binary search tree. That when data is sorted, so we apply there BST. Okay. Now next thing is where is the importance of data structure and algorithm? Efficient data storage and access, that I told you. Scalability. Now see, if there is small data, you don't need like particularly any data structure. Like I want to find out of average of I have just 5 students and average of 5 students marks, so I don't need like data structure, arrays or something like this. I can use 5 variables and take 5 students roll number, and you can say 5 students marks and find out the average. It's simple one. But same, I have 60 students and I want to find out average, then those I cannot take 60 variables to store 60 students marks. It's really hectic. And not 60. Now obviously we are managing a lot of data when you are dealing with projects, so we cannot simply take variables. When there is large data set or huge data, then we need data structure to manage that data. Okay, so scalability means data structure enables the programs to handle larger data set and more users. Like I want to handle 1,000 students, I can easily take an array of size 1,000. Simple. I don't need to take 1,000 variables. It's very simple for me, right? So that's how scalability is there. Organization. DSA helps obviously organize the data and program in a structured manner and obviously in memory efficient way. Data structure helps in memory efficient storage of the data. I've told you now, when you're going to pack a suitcase, then if you properly fold your clothes and roll up the socks and these things and properly put one after another, something like this, you can easily pack a lot of stuff in that one suitcase. But if you do not organize, you put everything like in the unorganized way, then maybe you need extra bag to store these clothes, those clothes. So using data structure will definitely store the data in a memory efficient way. Now, and DSA also essential for, in general, if I say, then interview kind of thing. Top tech companies, FANG companies basically ask DSA in their interviews, in coding round and face to face interviews as well. They have they conduct many hiring challenges at first to filter out many students. So in there also they ask questions based on DSA. So for interview for placement kind of purpose, also DSA is important, data structure and algorithm. And obviously it is going to improve your problem solving skills. So it is a tool for solving complex computational problems, like we can say Google Maps. Simply you can find out route from one location to another location. Okay, so that use nothing but, you can say, that data structure like graphs, diastro algorithms, to find out the shortest route. So those real life, real world example, real world applications are also using DSA, data structures, okay, to solve, you can say, those problems, real world problems. DSA is really required. Search engine Google use hash tables, trees. Social media apps use the same, like hash tables, graphs, to store the data, to give you faster, whenever you are going to search, you give answer of that question quickly. So for that they use like hash table kind of thing. If you want to retrieve the data quickly, we use a data structure hash table, key and value pair. So we'll see later all the data structures. So every application implicitly or explicitly use data structure. Without this, nothing. No, you cannot write any application. If you do not use any data structure explicitly in your program, internally it is using, implicitly it is using data structure. I have told you now, when we're going to run a program, then there is a stack kind of thing. So stack is nothing but a data structure. When you are running that program, running that program, when you are calling the function, then there is a stack. One stack frame is pushed into that stack, and also internally it is using data structure. Or externally, we can use data structures to arrange the data. Okay, arrays we have used, like we have done with arrays, na? So array is nothing but a data structure, the simplest data structure, right? So these are, you can say, some and one more thing. If you do not use any data structure, then maybe to solve a problem you need to write down a complicated or complex algorithm. Like if you want to find out any book from there's a library, there are thousands of books. These are not organized. So if you want to find out, you want to write a program to find out any particular book into that library, maybe you need a complicated algorithm to find out a book. But second way is, if the books are properly arranged in the shelf, according to, maybe alphabetically, according to that category or the size or something like this, according to their genre and this thing, then you don't need a complicated algorithm to search any book from that library. Yes. So there also, that's why also we use data structure. So someone said that bad programmers focus on algorithms, on like programs, how to do that task. Good programmers basically focus on the finding the good data structure. They use the right and the good data structure to store that data, so that they don't need to uh, write down a complicated algorithm to solve that problem. So try to choose the right data structure, a good data structure. Okay, and that also depends on many factors according to your need. Like suppose if you have a fixed amount of data and you don't need frequent insertion and deletion in that data, you need sequential access, and you need some random access also. You can directly use arrays. Directly, randomly, we can access any element based on the index, right? And arrays are like fixed size, so arrays are better. But if you need frequent insertion and deletion from the data, then, and the size is also not fixed, it's dynamic, then we use linked list, because inserting a data in the linked list is simple than the inserting or deleting from array. Why so? Because it's something like this. Linked list is something like this. There is one node, it's linked with the another node. It's linked with another node. So like this contains the address of this node. This part contain address of this node. Here is data, here is data, here is data. Something like this is linked list. So if you want to add something, suppose here I want to add. So I can simply add here. I can just update this. This will link here and this contain address of this. Simple. If you want to delete, that is also simple. But in array, it's not possible. Array is contiguous memory location. So here we have some data like 1, 10, -1, 0, 10, something like this. If you want to insert something, then first thing the size of the array is fixed. But that is also like there are some ways we can increase the size and all. But suppose here I want to insert something or I want to delete the data -1. So to delete this, so you have to move this. Here we have 0, here we have 10. So it's really like you can say complicated kind of thing. So when you need frequently insertion deletion in your data, use linked list. So according to your need, choose the right data structure. Okay, that's very important. Now, if you need frequently insertion and deletion, and there you need arrays, it will not give you much advantages of using data structure or organizing the data. Okay, so better to choose the right data structure. So good programmers always focus on the data structure. Bad programmers focus on the algorithm, how to do the task. Okay, now this is like basically you can say need of data structure and algorithm or the importance of data structure and algorithm. So we can say without data structure, managing and processing the large amount of data would be really slow and inefficient. That's why we use data structure. Okay, now the impact of efficient algorithm. We use algorithm also. I told you there to solve a particular problem. There are so many algorithms like sorting algorithm. We have searching algorithm. We have there are so many algorithms to find out shortest route from one location to another. There are many algorithms, but we choose the efficient one. Why so? Because faster processing. Efficient algorithm reduce the time it takes for a program to execute. The time complexity would be less if you go for a better approach, better algorithm, optimized algorithm. That's why in interviews they always go for optimized approach. They always ask like optimized approach. Okay, so that it because it reduces the number of CPU cycles and the time and all. And those CPU cycles and that time could be utilized in some other way, other productive way. So a program should take less time to execute. That's why we have to use efficient algorithm. Okay. And same that resource optimization I've told you. Like they minimize the use of computational resources like CPU and memory. Less CPU cycle, less memory if you use an efficient algorithm. Okay, but this thing comes with practice. Don't worry. How to solve a particular problem? What is the optimized approach? These things comes with practice. If you're a beginner, then you don't need to worry about these things right now, about the optimized approach right now. First, you have to focus on how to solve a problem. That's it. Any approach you can take. Brute force will work. But after that, ultimately, obviously, you have to learn how to find out that optimized approach to solve a problem. There are so many approaches. Or you can say approach means like algorithm. I'm saying algorithm. Okay. Now, there are some real world applications of data structures like social network. Social networks we use graphs. They use graphs to model the relationship between users. Search engine they use hash tables to index and retrieve the web pages quickly. And databases trees are used for indexing and organizing data. So every application is using data structure, different data structures, right? Now we have choosing the right data structure. So this is the important one. So analyze your requirement, your need first. Understand the specific operations that need to be performed on the data. What is need of your project on which you are working? According to that, first analyze that thing, and then obviously you will having maybe some constraint also. So take into account those constraint like memory limitation and processing power. Based on that, You have to evaluate the trade-off. Different data structure offer different performance characteristics. Maybe some takes less time, but they will use more memory. So there's a trade-off between the time and the space and the memory and all. So you have to consider all these factors and then choose the right data structure according to your requirement. But right now we don't need to worry about choosing the right data structure, because we have to study first all the data structures, and then with practice this thing will automatically come to you. Okay, which data structure, if this kind of problem is there, these kind of operation would be performed here. Okay, so I have to use this data structure. But this thing comes in your mind when you have the knowledge of all the data structures: arrays, linked list, stack, queues, trees, graphs, tries, everything. Then only you can come to know to this conclusion that how to choose the right data structure. So for now you don't need to worry about this thing. Okay, this is just for a, you know um just to tell you that, okay, this point is also important, that choosing the right data structure. Okay, now that's it about the introductory part of data structure, algorithm, why we need data structure, and importance of, you can say, data structure and algorithms. That's it. Now in the next video we'll see classifications of data structure, and then we will see those bigger notations and all. So now I'll see you in the next lecture. Till then, bye bye. Take care.